Hi everybody, this is Regents Spiral number 6. This is finishing up the White Regents, June 2024. All right, here we go. Question 15. The equation that represents the sequence -2, -5, -8, -11, -14 is, okay, so it looks like it's arithmetic because all of these are following the structure of an arithmetic sequence formula. So that looks like a sub n is equal to a sub 1 plus d times n minus 1. So it looks like if we just figure out what the common difference is, we can pick our answer choice and determine which one is correct. So let's go ahead and find the common difference for here. So to get from -2 to -5, I'm going to subtract 3. Let's just double check that that holds true for the second one too. To get from -5 to -8, do I subtract 3? I do. So the common difference is going to be -3. So I'm just going to pick the answer choice that has a common difference of -3, and that's choice 2. Okay, let's look at question 16. We have a dot plot, and then I see that the question choices are asking me about a bunch of one-var stats. So what I'm going to do is read the question, and then I'm going to end up putting this dot plot into my computer, or calculator, sorry. So it says the dot plot below shows the number of goals Jessica scored in each lacrosse game last season. Which statement about the dot plot is correct? So it looks like I need to calculate the mean. Remember on our calculator, mean looks like x bar. I need to find the mode. The mode cannot be found on our calculator, but we can just look for the highest column of dots, and that occurs at 3. And then we need the median. So let's go ahead and enter these into our calculator. So I'm going to go to a list and spreadsheet, and I'm going to type in, remember for dot plots we have an X list and then we have a frequency list. So let's go ahead and type this in. So for every X we have 0, 1, 2, 3, 4, 5, and 6. And then the frequency of each one of those numbers of goals is 0 happened 3 times, 1 happened 3 times, 2 happened 4 times, 3 happened 5 times, 4 happened 2 times, 5 happened 2 times, and 6 happened 1 time. We're going to go ahead and calculate the one variable statistics for this dot plot. So I'm going to go to menu, 6, 1, 1. There is only one list because if I listed this out, the data would look like just a big, long, singular string of values, right? So there's only one list, but I do have an X list and a frequency of each X list. So now my mean is going to be 2.5 and my median is 2.5. Therefore, the mean and the median are equal. It's answer choice 2. Question 17. The students in Mrs. Smith's algebra class were asked to describe the graph of g of x equals 2 times x minus 3 squared compared to the graph of f of x equals x squared. So it looks like we have a 2 out front, so that is going to make the graph narrower. Remember, if there's a fraction, it gets fatter or wider, whereas if there's a whole number out front, it gets narrower. The -3 inside of parentheses tells me that we're going to be going right 3, and then those are the only transformations that I see. So I'm looking for narrower and right 3. My answer is choice 4. Question 18. One Saturday, Dave took a long bike ride. The graph below models his trip. What was Dave's average rate of change in miles per hour on this trip? So in miles per hour on this trip means all the way from 0 to the end of his trip, which happened at 5.5 hours. So let's go ahead and calculate the slope between those 2 points. So at time was 0, his distance was 0. And then at 5.5, when the trip was over, his distance was, what are we counting by here? 2, 5, let's see, we've got 2, 4, 6, 8. Wait a second, how many lines are in here? 4, so 10 over 4. That's so weird. Okay. It looks like we're going up. This is halfway between at least, so that'll just be 55. Right? 50 to 60, this is going to be 55. Okay, so now I'm going to find my change in y over my change in x. Change in y over change in x. And that's going to give me, let's see, 10. Answer choice 1. 19. Which expression is equivalent to? So we love seeing the word equivalent because that means we can check our answer in our calculator, right? We're trying to see which expression is equivalent to x minus 5 times 2x plus 7. So I'm going to do this binomial times binomial with a box. And then after I get whatever trinomial results from that, I'm going to subtract off an x plus 5. Okay, no problem. I'm going to fill out the sides since I am simplifying. So that is the trinomial that's going to go right up in here. And then now I need to find out what's going to happen with this. So I have 2x squared minus 3x minus 35. And then I'm subtracting off an x plus 5. So that means I'm going to distribute the negative to each term in the parentheses. And now I get minus x minus 5. So I'm going to combine my like terms here. And I get 2x squared minus 4x minus 40. And that's going to end up being answer choice 4. And I can check that on my calculator by storing a variable for x. So I'm going to go ahead and store a 2 for x. What? Oh, okay, well then let me start a new one. Okay. That just means I had listed like a spreadsheet or a list as the variable x, so now it like got mad at me, so I just opened up a new document. All right, so now I'm going to test x minus 5 times 2x plus 7 times, oh sorry, that's subtract, minus x plus 5. And that gives me negative 40. So let's check our answer choice and make sure it should be negative 40. It is, yay, we're right. Question 20. The functions f of x and g of x are graphed on the set of axes below. What is the solution to the equation f of x equals g of x? The solution are the x, or the solutions in this case, are the x equals. So this point of intersection section happens when x equals 1, and this point of intersection happens when x equals 2, 3, 4, 5. So my answers are going to be 1 and 5. All right, 21. When babysitting, Nicole charges an hourly rate and an additional charge for gas. The additional charge for gas is the one-time fee. That's going to be my y-intercept, and the hourly rate is going to be my slope. She uses the function c of h equals 6h plus 5 to determine how much to charge for babysitting. The constant term of this function represents the charge for gas. So that's going to be what answer choice 1. When solved for x in terms of a, the solution to the equation 3x minus 7 equals ax plus 5 is, okay, so I'm solving for x. That means I'm going to isolate x. I'm going to sort everything that contains an x over to the left, and all the constants are going to go over to the right. I now have 3x minus ax equals 12. In order to get x by itself, I'm going to have to identify the greatest common factor of these two terms, which is x. I'm now left with a 3 minus a in the parentheses. If I'm trying to get x by itself, what is the operation between x and 3 minus a? It's multiplication. So if I want to get x by itself, I'm going to divide both sides by 3 minus a. And I'll get x equals 12 over 3 minus a. And that is answer choice 2. Okay, question 23. It says, Wade Van Nykirk, a runner from... that's actually a real person. I remember seeing him in the Olympics. Anyway, ran 400 meters in 43.03 seconds to set a world record. Which calculation would determine his average speed in miles per hour? So now we just have to look to see which set of fractions has the units canceling correctly. So remember, if we see the units next to each other, meters and meters both on top, that's not going to work. Down here, I see seconds and seconds both on the bottom. That's not going to work. Here, seconds and seconds will cancel. Meters and meters will cancel. It's answer choice 3. 24. Which function has a domain of all real numbers, meaning the graph has no start or stop, and a range greater than or equal to 3? Okay, well, let's graph all of these and see what they look like. So in the first one, I have negative x plus 3. When I graph that, it definitely has a domain of all real numbers, right? If I zoomed out, I could just keep zooming out forever. It could take on any x value, and it's fine. And a range greater than or equal to 3, well, no, this guy's range is all real numbers, so we're going to exclude that. Let's type in the quadratic now for answer choice 2. X squared plus 3. Okay, so his range begins at 3, including 3, and goes up to all real numbers. And he has a domain of all real numbers, so his answer is the answer is going to be choice 2. Okay. We did those ones. Let's head over to 29. So I'll see you on page 29. Or not page 29, sorry. I'll see you on question 29. Okay, so on question 29, it says use the method of completing the square to determine the exact values. That means my answers are going to look like x equals and then some radicals of x for the equation right here. So if we have to complete the square, the first step that we're going to do is rewrite with space. In those spaces, I'm going to set up for my magic number. Inside the parentheses, I add. Outside of the parentheses, I subtract. I find that magic number by taking the b term, or the coefficient of the plain old x, and I have it, then I square it. 10 divided by 2 is 5. 5 squared is 25. 25 is my magic number, and I put it into the boxes. Then I'm going to factor this trinomial using a box or just using your head. I'm looking for the factors of 25 that add up to positive 10. They are 5 and 5. They must both be positive to add up to a positive 10. X. Therefore, this trinomial now factors to the binomial of x plus 5 squared. I combine my constants out back here. And now I need to solve. So I'm going to add the 55. I now have x plus 5 squared equals 55. I'm going to square root both sides. I get x plus 5 equals plus or minus the square root of 55. Let's just double check that 55 doesn't have any perfect squares as factors. I'm pretty sure it doesn't, though, just looking at it. Yeah, I don't see any perfect squares. Okay, I'm just going to move the 5 over then. The plain old negative 5 goes out front. plus or minus the square root of 55, and that's my answer. All right. Question 30, factor completely. When I see the word completely, I'm going to write GCF. I'm going to look for a GCF in 20x cubed minus 45x. So it looks like they both share an x, so that's definitely going to be the GCF, but then there's also a constant out front. And do you remember the trick I showed you guys? If you're not sure what the GCF of two numbers is, you can go to a calculator page, you hit menu, 2 for number, 5 for GCD. So menu, 2, 5. I'm trying to find the greatest common divisor of 20 and 45. That means the GCF pretty much. And it's 5. So now my GCF is not just a plain old x, but it's a 5x. So 5x goes outside the parentheses. I'm going to work piece by piece. 20 divided by 5 is 4. X cubed divided by x is x squared. 45 divided by 5 is 9, and x over x cancels. I now see that this is a special factoring pattern. We have the difference of two perfect squares. When I have that, I have a 2x in the front of each because I take the square root of the first piece. I put a plus or a minus to get the minus in the middle, and then I take the square root of the last piece. There's nothing else that I can break down any further, so that is my answer, and I am done. Okay, what is the next question that we have to do? Let's see. 33. Okay. Use the quadratic formula to solve the equation 3x squared minus 10x plus 5. Express your answer in simplest radical form. Okay, so I have to use the quadratic formula, so that's my method. And my answers are going to look like x's with some radicals. So let's go ahead and double check how we do the quadratic formula. Remember, if you forget on the day of the test, you have your reference sheet, and it is this. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We know that the b squared minus 4ac all under the radical is the same thing as the discriminant, and it's all over 2a. So let's figure out what the a, the b, the c, and the disk all equal, okay? So a is 3, b is negative 10, c is 5. The discriminant is negative 10 in parentheses. Do not forget the parentheses. You will get the discriminant wrong. We're going to type that into our calculator. And I get 40. So the discriminant is 40. I now plug this into my quadratic formula. Negative b plus or minus the square root of the discriminant all over 2 times a. Let's see if we can simplify. Negative 10 becomes a positive 10. The square root of 40 needs to get put into simplest radical form. Excuse me. That's going to be the square root of 4 times the square root of 10. The square root of 4 is plus or minus 2, radical 10. That is my simplest radical form of that thing, all over 6. Now we're going to do the heart trick and see if we can reduce. X equals 10 over 6 plus or minus 2 radical 10 over 6. So let's type each one of these into our calculator and see if they reduce. 10 over 6 reduces to 5 over 3. And remember, I'm not typing in the radical, I'm just typing in the coefficients to see if they reduce. So I'm typing in 2 over 6 and I get 1/3. And then that is my answer. You also could have got an answer that looked like this, and that is totally fine. Both are okay. All right, 34, graphing a system of inequalities. Here we go. I'm going to go to a calculator page. I mean a graph page, sorry. And I'm going to type these in. Y is not by itself in either one of these, so I'm going to delete the equal sign and put this in relation mode. I now have 3y plus 2x is less than or equal to 15. I'm just going to graph one at a time, so that way I make sure it's perfect, and then I'll graph the second one. So let's get some points on this thing. We're in relation mode, so we can't use the table. We have to use the graph trace. Let's pick only the nice points on this line. So I'm currently doing this line, and he'll be black. So I have -6. Okay. Okay, and this has a less than or equal to symbol, so that means that the line is going to be solid. I must label my line or I lose silly points. And then I have to look at my picture on the graph, and it looks like I shade down from there. Make sure you're not scribbling. Your lines should just be nice little parallel lines. Now let's do the second line, and I'll do it in a different color. Let's do it in red. On the same graph, I'm going to add tab for a second relation, and this one's going to be y minus x is greater than, oh my gosh, what did I just do? I don't know where it went. Y minus x is greater than 1. Okay. Now for this one, let's get some points. I already told it to count by 1, so now I can just hit up and get onto that red line there. So it looks like 9, 10 is my first point. Okay. Then I have 6, 7, oh, your favorite. It's okay that they don't cross at a nice point. I feel like that would bother you. It's okay. It's not always going to be perfect, right? Okay, and then this is a dashed line because of the inequality symbol type. Okay. And then on the picture, it looks like they shaded up. And then I'm going to mark my solution region with a big S. And that is the region that contains all the solutions. So it says state the coordinates of a point in the solution to this system, justify your answer. So I just have to pick a point that's in the S. I'm going to pick one that's safely in the S, not right on the line. I know you guys love to live on the edge here. Let's choose -9, 2, and then just double check that the point you chose is in fact in the shaded region. And then we'll say that is a solution because it is in the region where the shaded parts overlap. All right, 35. Courtney went to a coffee shop to purchase lattes and donuts for her friends. One day she spent a total of $15.50. That's a total on 4 lattes and 2 donuts. Okay. The next day she spent a total, that's another total, of $18.10 on 3 lattes and 5 donuts. All prices include tax. If X represents the cost of 1 latte, and y represents the cost of one donut. Write a system of equations that can be used to model this situation. So the first total is $15.50, and that came from buying 4 lattes and 2 donuts. The second total is $18.10, and that came from buying 3 lattes and 5 donuts. Courtney thinks that 1 latte costs $2.75, so she thinks that's the X, and 1 donut costs $2.25, that's the Y. Is Courtney correct? Justify your answer. Justify means I need to show with some algebra what's going on here. And they love giving this question, right? Because you test that value of X and Y in one of the equations, and it usually works for just one, but it needs to work for both in order for it to be a solution to the system. So they're just checking to see if you're only going to check it in one equation, but you can't get us. We're going to check it in both because we know better. In order to be a solution to the system, it must work in both. So let's go ahead and check. Okay, so now we're on a calculator page, and I'm doing the first one. 4 times 2.75 plus 2 times 2.25, and that equals 1550. So we would write 1550 equals 1550. It works for that one. Let's try the second one. What did I tell you? They always pick one that it doesn't work in. So you would write 1950 does not equal 18.10. And then you would say, since this combination doesn't work in both equations, they can't be the prices. Use your equations to determine algebraically means I need to show all the work for how I get there, the cost of 1 latte and the exact cost of 1 donut. So whenever I'm solving a system algebraically, I always like to get my answer first so I know along the way if I'm on the right track or not. So I'm going to go to menu 3.2, system of linear equations, and I'm going to type it in. Get my answer, and then know where I'm headed. Okay, so a latte should be $2.95, and a donut should be $1.85. Okay, so let's prove that algebraically. Use your equations to determine algebraically, that means we need to show all of our work, the exact cost of 1 latte and the exact cost of 1 donut. All right, so I typed this in. Sorry, my video got cut off. Someone came in my room earlier. So I'm just kind of picking up where I left off. So we have the answer already from the calculator, and here we go. So we have the 2 equations, and I'm going to solve them algebraically. When I have the x's lined up with the x's, the y's lined up with the y's, and the constants lined up with the constants, the method that I am going to choose to solve this algebraically will be elimination. So if I'm choosing elimination, I thus have to pick a variable that I'm going to eliminate. And I'm just going to pick x because it's in the front. Neither of these can be scaled up to the other. Like if one up here was a 2 and the other down here was a 4, like then I would pick this one and multiply it by -2 because then they would cancel, but none of them can be scaled up to one another. So I'm just going to do the cross coefficients trick. So the 3 is going to come up here, the 4 is going to come down here, and I'm just going to make one negative. Now I distribute that to each term in the parentheses. And now I'm going to add them both together. And when I add them both together, negative 12x plus 12x will cancel. 6y plus, negative 6y plus 20y is going to give me 14y. And then negative 4650 plus 7250. 7240. There we go. Is 2590. I'm going to divide both sides by 14. And I get $1.85, which is exactly what I got up here. So yes, we are partially correct. Let's check out what x is. When I have one of the variables solved, I take that variable and I plug him into an original. What do I mean by an original? I mean one that has not been multiplied, distributed, anything like that. One of the original problems. One of the day ones. So I got 2y equals 1550. So I'm going to take out the y that's right here and I'm going to put in the $1.85 that I just found. Now I'm going to divide both sides by 4. I get 295. Yes, that was the other one. Okay, we got both the answers.